applications continue, basically is an extension of determining equations of sinusoidal functions. Except for the fact you might not be given the graph, you might be given information that you can sketch on a graph and then come up with the equation of it. Okay, so it's just one more step. It might be data that's given to you or a real life situation, and then you have to interpret that, then put it into an equation. So here's the first one. So the maximum tidal height at a port on the east coast of Nova Scotia is 4.2 meters at 6 a.m. The minimum is 1.2 meters at 12:15 p.m. Relationship between the tidal height H and the time hours is sinusoidal. Anyone been to, in this case, Nova Scotia?
I want to be there.
Or the West Coast? You've been? Yeah. You guys haven't lived on the ocean then, probably. Or maybe you have in some other places. You know, it's more than just West Coast. But in Canada, so I grew up in Victoria. So this kind of makes sense to me in terms of that tidal height. So they're measuring it at a port, right? Where there's like the dock. So they can measure when it's at that 4.2 meters or when it's lower, okay, based on that. It comes in and out about twice a day. Okay. I lived in Bermuda, as I mentioned to you guys a few years ago. That's on the ocean. Way closer, I lived right on the ocean when I lived there. And so the tide would come in and go out. Important, like, a lot of thinking has to go in, especially in a place like Bermuda. They get all their goods by boat. So the cargo ships, they can't come in at certain times of the day to certain areas because the water will be too low, the tidal low, right? Same with cruise ships. If you've ever seen, so in Victoria, where I grew up, cruise ships would come there. They come in at certain times of the day, and like in Bermuda as well. They come in, get their passengers, if they wanted to go for a day tour or whatever, they go out. But the boat would go back further away from the dock, where it wasn't an issue, it's so deep that there's no issue with tides. Then they go back when the tide was high again, so that they don't run aground. You can Google search. It's probably now more like 7-8 years ago. There was a cruise ship, I think it was in Greece, that it was actually literally, like, you could probably, well, for sure swim, and some people swam to shore, but it didn't predict the tides properly, so it ran around, tipped over, because there wasn't enough water, right? They didn't go in at the right time, so they ruined the cruise ship, and people got injured because you start taking the whole ship over, there's stuff on the ship that you're going to get hit by, right? So it's an important thing to be aware of. So when you get older, you can go traveling and smell the ocean because it smells lovely usually. In any case, sketch a graph for the height as it relates to time. So what's time? These are times of day, and we're talking 6 a.m., 12:15 p.m. So I would start maybe at midnight for a whole day. So this will be, and I'll call this time in hours after midnight. So I'm giving you a little hint here of what your horizontal axis can be. Right? So here, at time 0, that's midnight. So then we want 6 a.m., let's say it's here. That'll be 6 hours. And that's a maximum tidal height of 4.2. Okay, remember this is a sketch, it's not exact. Then 12:15 p.m., so 6 more than that. You can estimate about the same and a little bit to the right of that. Now 12:15 How many hours is that? That's 12.25 hours after midnight. Because if you're going to do an equation, a regression, you're not putting 12:25. How do you do that in your calculator? You can't. You have to convert it to a decimal form. Sorry, 12:15. You can't put 12:15, but you can put 12.25. So that is 1.2 meters. So it says so about there. And so it's looking like this. Okay. And it's going to repeat. Let's think about what happens. So that's from a max to a min. Is my min over here going to be at 0 or going to be to the left or right of it? Think, that's close, just think. So this distance is from a max to a min. I want to find out where to put my min over here. Should I put it like out there, there, or there? Okay, hands up, who wants to share? Okay, I'm going to get someone different today. Josh? Slightly to the right. So if I put it here. Remember, mine isn't to scale, right? So now if that's to the right, and I do this, is that going to be the same distance? No. Slightly to the left. Okay? Because what's this distance? 6.25, right? So I want this to be 6.25, so it's going to be over here. So I'm just going to, that's why I use pencil, right? Fix that up. It's not, no one's fault. Okay. So that's a complete cycle, right? This would be negative 0.25. But at least we've got one cycle for right now, okay? That would be the previous day, right? We talked about that. Okay, so it says we have 2 full cycles. Not going to, okay? Not taking the time. So determine the equation that describes the relationship. Notice how it has a cos version, a sine version. It doesn't matter if A is positive or negative. So you decide whichever you want to do. Remember, A, B, and D are the same, either case. Although A could be negative, I guess. So let's think about where our midline is going to be. So remember, this value here was 1.2. That's 4.2. So my midline is going to be about there.
5.7.
Did you say 5.7? Okay, so 5.7 is way up here. Yeah. Halfway in between. How do you find halfway in between? You take the average. So 4.2 plus 1.2 is 5.4. Divided by 2 is 2.7.
What?
Okay, or the difference is 3. Half of 3 is 1.5 added on. 1.5 will be your amplitude. Don't get mad at each other if someone says the wrong value.
I just 6 meters.
Okay, and so that's plus 2.7 on the outside of both of them. Okay, so you got part marks already, yep. If it's given in decimals, you don't have to use fractions. Okay, can use decimals. If there's decimals in the question, that's when we can use decimals.
I mean, like, you could just use decimals always, but that makes life harder.
Okay, so this case, we already figured out from a max to a min was 6.25. For the period, we need double that, right? So the period is going to be 2 times 6.25, because a max to a min is only half of a mountain and half of a valley, right? So that's going to be 12.5. If you've graphed it like I have, remember that's negative 0.25 plus 12.25 is 12.5. So that's that's a complete cycle. All right, so now for our b value, it's 2 pi divided by 12.5.
It's just like,
So that is really a decimal within a fraction, which we usually don't like very much, right? You can change that. So I would convert it to a fraction form. You will, however, sometimes see in an application question a decimal within a fraction in some cases. So it may happen that way. But remember, this is 25 over 2, so that's going to be 4 pi over 25. You can. Okay. So, both of these have translations. Cosine is an easy one. If it's, well, I shouldn't say that. If we do negative cosine, it's pretty easy. It's right there. So if you want to do a reflection, because it doesn't specify what A has to be, then it will be starting at the minimum and going up and to the right. So we just need to move that 0.25 to the left. So this would be plus 0.25. If I put a negative leading coefficient. Okay. Now we have to think a little bit. So here's the translation for sine. Okay, I want to go to this point. So think about what that point is. You might think, oh, it's 3. It's not 3. Remember, from here to here is 6.25. So half of that is this, and half of that is this. So half of 6.25 is what, 3.125? So you can either go negative 3.25 plus 3.125 to get here, or 6 minus 3.125. But this is not going to be 3. Just be aware of that. I'm going to fit it in here, so I'm going to the right, and that's going to be, I have to do that math in my head. That's going to be 2.875, right? Okay, how do you check your answers? Turn off your plot. Enter negative 1.5 cos. You can use the fraction, makes it a little bit easier so you don't mess up on. Pardon?
oh, wait, no, you're not right.
And then 1.5 sine. Oh, actually, what you could do is go up. What are you talking about?
15 sine? 15 sine? That's gonna be a fun one.
Window, I'm gonna go from 0. Okay, folks? Are you guys checking, or are you just like partying while I do all the work? Oh. And when you grab this, put it into radio mode, if it's not already. Okay, it should overlap. If it doesn't overlap, then one equation is different than from the other one. Okay, but it works. Okay, and it looks very similar to that. You can check your max and your mins just to make sure.
How do you do the fraction again?
Alpha y.
Oh, got it.
Okay, we're going to answer some questions based on this. Guys, do you need some help with the calculator? You don't have a calculator?
Yeah, I probably need some help with calculating.
Okay. You get it on your own? It's not a group work thing. Okay, algebraically, so this says algebraically. So we have to use our equations. Determine the tidal height at 8 a.m. So I'm just going to actually dual page so I can see the equations. Okay, so doesn't matter which one, I'll use the cos. So I'm just going to copy it out. Okay. 8 a.m. is how many hours after midnight? 8. Okay, 8 hours. Take a look here. Just make sure. It says time is measured in hours. So that's good. We'll put 8 in here. Now, 8 plus 0.25 is 8.25. That as a fraction is what? 3233 over 4. And this won't be a special angle. So I think we'll still need to use our calculator, right? So we can find the fraction form of that with the calculator helping us, right? So 8 plus 0.25 multiplied by just 4 over 25. Leave the pi out, right? Okay. That is not a special angle. We don't have any special angles from what we've learned so far anyway, that have a denominator of 25, right? So we will learn some what we call identities to help us find some more special angles, but right now that won't work. So now we'll use our calculator. Again, it needs to be in radian mode, negative 1.5. So even though it says algebraically, we've done our work in there, right? And we're just using our calculator to get the value of cos. Because it does say to round, so. So notice I don't bother with the fraction form when I get it down to one of them. It just takes a couple extra presses in the calculator, and I find that annoying. So I just do that, close the bracket, plus 2.7. Determine the first time after 6 a.m. that the tidal height is 3 meters. So, determine, doesn't say algebraically, so say what we're graphing. So, either one of these, right? So, y1, maybe you want to, we'll do it with this one just for fun. Again, 6 a.m. is 6 hours after midnight. We already graphed those.
Is it y is supposed to be 3?
Oh, the first time after 6 a.m. that the tidal height, oh yeah, it's supposed to be 3, sorry. Thank you. So, this y is the height, so I put 6 in there. We want to just find the first time after 6 a.m. because there's also this time in here that will have a height of 3, but we want it to be after 6 a.m. So we want this one here, the first time after. So I'm going to use sine in my, well, pretend that's y1 and I'll copy the whole thing out again. Doesn't matter. Then remember, so you do this first, then your window settings. Okay, so what did we do for our window settings? We went 0 to 12.5 up by 1s. We went 0 to 5 up by 1s. Okay. Then we want to find the, in this case, so we entered, we should probably change this to an x. In our calculator, that's what's in there. So using x and y, then find the x value at the point of intersection to the right of 6 a.m. Okay, so now second trace intersect, enter, enter, enter. Okay, so let's convert that to hours and minutes. How did we do that before? So first of all, I'm going to copy my x out. Okay, I'm going to subtract 8. So that's going to be 8 a.m. Obviously not 72 minutes. Multiply that by 60. And that's going to be 843. We'll use regular rounding rules. Even though really, you might say 44. Okay, so Okay, so we're not going to have much time to get through example 2 and 3, so we'll finish those on Monday. You can also look ahead. We might only do one of those together. Anyone had a slinky before? Yeah, so example 3 is for you. Never had a slinky? Slinky, slinky. Okay, so example 2 is during deep sleep. Hopefully that doesn't happen during class. Are you awake? Looks like you're in a deep sleep. A person's breathing can be very irregular. The volume of air in the lungs follows a sinusoidal relationship that varies from 100 milliliters to 500 milliliters over a 5-second period interval. Sketch a graph representing the volume as it relates to time. If at the moment the person enters deep sleep, the volume is 3,000. So, let's do X and Y axis. You can go at theta if you want, up to you. So it says that the time 0, so this will be time, and this is in seconds. At time 0, it's going to be 300. So 300. 3,000, sorry, 3,000. Okay, and this is volume. So actually I'll use E for that. And then it varies from between 1,000 and 5,000. So when they're entering deep sleep, the volume is 3,000. So we're going to assume that they're entering deep sleep, so they're going to be on the increasing and decreasing. Now, saying that, let's figure out if my scale is decent here. So this has to go to 5,000. And my minimum is 1,000. So I'm actually going to draw a midline here to help me. Remember, this is a sketch, so it doesn't have to be perfect. So now I'm going to go down to 1,000 and up. That's not bad. I'm just going to do one cycle. Okay, minimum, maximum, yeah? It'll be obvious on a test if you have to do it, yeah. Okay, this one you could actually go down, right? Because maybe if you're not sure entering deep sleep, if you're actually breathing in at that point. So this one is a little bit ambiguous, but on a test it'll be obvious what happens. We'll make sure. Okay? So it says varies from 1,000 to 5,000 over a 5-second interval. So this 1,000, if you go up to 5,000 or back this way, that has to be 5 seconds. Okay? So let's think about what time interval this is. Remember that this is 5, that's from a max to a min, which is half a cycle. If you're going from a max to a min or a min to a max. So a complete cycle then would be 10 seconds. So from here to here would be 10 seconds. Okay, and so this would be 5 here. This would be 2.5, this would be 7.5. Okay, because a sinusoidal is a mountain and a valley, and each of those are cut into half. Okay, so that's a sketch. It says determine the equation that relates the volume, V of t, time in seconds. So this is from the midline and the vertical axis going up and to the right. So that's a sine graph is going to be the easiest to use. Positive sine Okay? And we need to get the amplitude. So you can draw it in, you can calculate it. Really, I don't need to see the calculations for that. I'm not going to care about that. It's right or wrong with the amplitude. Okay, and then we'll figure out our argument here. We know our D value is 3,000. So even just doing that part would get you part marks, right? Right? That gets you part marks. It doesn't get you all marks. So then, thinking about this, there is no translation, but there's certainly a horizontal stretch. So remember, a regular sine graph is 2 pi. Now this period is 10. So B equals 2 pi over 10, and reduce that. So that's going to be pi over 5t. Okay, and then if the person falls into deep sleep at exactly 1 a.m., then algebraically determine the volume in the lungs at 1:10 a.m. Okay, so this is time 0. That's when they fall into a deep sleep. So t equals 0 here. So remember, t is in seconds. So determining the volume at 1:10 a.m. is 10 minutes later than when they fall into sleep here. But this is in seconds. So we need to basically convert 10 minutes into seconds. How many seconds in a minute? 60, so the answer is 600 for, yeah.
600 seconds in a minute. Like, your minutes are way long.
So 1 minute equals 60 seconds. Okay, so 10 minutes is 600 seconds. Try it without a calculator.
Like it was like okay, so like if this is the graph, you go to universal or is it just
Sine of 125. What do you think?
that's
0, 1, root 2 over 2,
that's
3 over 2.
it's divisible by 2.
It's divisible by 2. 2 pi, right? Goes into that evenly. So that is going to be coterminal with 0 radians, or 2 pi radians, right? Or 0 degrees, whatever you want to think about. And so the sine on the horizontal axis is always 0. So this is just going to be 3,000. And this is millimeters. Now, if you had used your calculator for that, you'd get the same thing. If it had been the sine of, I don't know, coterminal to pi over 3, then your calculator would give you a decimal. We'd probably ask you for the exact value. So we want to see pi over 3. But want to see the root 3 over 2 in there. So this, your calculator would do it for you. Okay, so as I said, I'm going to skip number 3 with you, and we're going to do the Ferris wheel on the next page.
Very funny.
Anyone heard of the movie Ferris Bueller's Day Off?
Okay, everyone's answering up.
2, 6.
Okay, so homework is to go watch that movie.
So this means when your teacher like me or any other teachers are, when it's silent and we're asking a question, sometimes they'll go, Bueller, 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 right? You see the movie? Yeah, because the class just sits there and doesn't do anything while the teacher's asking a question, right? And he's asking Bueller, Bueller. Okay? Anyway. Yeah, he takes a day off from school. Day off from school. And he goes and gets trouble. Takes the car and drives it. Yeah, he does a lot of things on his day off. Okay, so who's been on a Ferris wheel?
What?
Okay.
Oh, yeah.
Yeah, Ferris wheel. Okay. That's good. If you think about even when you were younger and maybe went on a merry-go-round, that's just a horizontal Ferris wheel, basically. Okay. Except that merry-go-round. Let's see, please. Merry-go-round, you control how fast you go, right? Ferris wheel, someone's in charge of that. Like there's a whole mechanism and they keep it going at a constant rate. So that's what we're looking at here. So I really need quiet, you guys. So Ferris wheel has radius 5 meters and its lowest point is 0.5 meters above the ground. Sam gets on at the bottom of the Ferris wheel and it takes 8 seconds for him to travel from the bottom to the top. We'll be examining the relationship between Sam's height and the time he is on the Ferris wheel. Okay, so complete the following table of values. So at time 0, it says he is 0.5 meters on the ground. It doesn't want to be 0 because then the cart that you're sitting in is going to scrape the ground. Right? It's got to be a little bit above. So it takes 8 seconds for him to travel from the bottom to the top. So how high, we're going to go straight to 8 here. How high will he be above ground when he's at the top? Check again. The radius is 5, 10.5. Add the diameter.
What said? Or did someone not say 10.5?
I think someone said 5.5. Okay? So 5.5 will be after 4 seconds. We're assuming it's rotating at a constant rate. Okay? So at 4 seconds, he will be at the same height as the center of the Ferris wheel. And that will be 5.5. Then another 4 seconds, we'll go in fours. He's at the maximum height there. So the next 4 seconds, he'll be back down to 5.5. And then he'll be back down to the bottom after 16 seconds. 8 seconds to go from the bottom to the top. So complete rotation is double that. So that basically tells you the length of your period, 16 seconds. Then the next 4 seconds, we'll be back at 5.5, so he's on his next round. Then 10.5, then back down to 5.5 and 0.5. Okay. So, graph is there for you. We'll call this T and H. And so 0.5 at time 0 is there. 4 seconds is 5.5. 8 seconds is 10.5. 5.5. 0.5. have to put in the curve yourself based. You don't have all the data values, right? So do not do straight lines. Do your best to try to show it in curve. I'm going to do my midline. Okay, so looking at the equation, it says come up with the equation as a sine function, not a cosine. Cosine would be easier, because really that's, if you reflect the cosine function, your minimum's at time 0, so there would be no translation. But it says to use sine. So from the midline up to get the amplitude, that's 5. What's special about 5 when we just read the description, the radius? So the amplitude is going to be the same as the radius in these circle rotation questions. Okay? Okay, sine. Then D is 5.5. That's the height of the center of the circle, what it's rotating on. Okay? So 5.5 is the height of the center of the circle. So it's basically the height that you get on plus the radius. Okay? Then B, remember, is 2 pi. We always use radians in this, not 360 degrees. So it's 2 pi divided by the period, which is 16. We talked about that. The time it takes to go a complete rotation on the Ferris wheel. And that reduces to pi over 8. So that's going to be pi over 8. Okay, T. And there is a translation, so I need another set of brackets in here. Okay, because sine, if I keep this positive, the closest is to the right, where it's going up and to the right, and that is 4 to the right. Okay, now the units in this are seconds. So this is based on time, and so time is in seconds in this. Okay? So it's kind of weird when you think about radians. It's not representing an angle. This is representing now time. Okay? Modeling this situation. Okay, so what is 4? So if you get on the Ferris wheel at the bottom, then this translation is always going to be the amount of time it takes to do a quarter of a rotation to get on at the bottom. Okay, so you're getting on here. You want to go to the midline, which is where you're parallel to the center of the circle, across from it. And so that's going to be a quarter of a rotation. It took 16 seconds to complete rotation, so 1/4 of that is 4 seconds. Just if you didn't graph it, right, and you're just trying to figure it out without actually graphing the Ferris wheel function. Okay? That's it. So how do those parameters, we already talked about it. A, we should probably put in an absolute value of A in case we did, say, a cosine or a reflection for sine. The absolute value A is the radius of the wheel. Okay. D is the height of the center of the wheel. Okay, that's the easiest way to say it. I guess you could say it's the height after doing a quarter of rotation if you get on at the bottom but that's the easiest way to describe that. Okay? Okay, get your calculator out. Just grab this. And do the same window as your chart, right? 0 to 32. Oh. And 0 to 10.5, so let's go to 11. Okay, determine the height of a rider at 9.3 seconds. So 9.3 is the X value in your calculator. So you can go trace, you just punch in 9.3 and it will go to that point. Round to the nearest tenth. So that's 9.9 meters. Then use your graphing calculator to determine how long a rider is 9 meters or higher in one full revolution. So that's your height value. So that's a Y value in your calculator of 9. So graph that. Okay. And we want just in one revolution. So this is 2. So we just want the difference here. Okay. So I'm going to find the intersection. Okay, and that I'm just going to write down 10.02 first. And I'm going to copy that out, that X value, out so that it's in there way faster, right? Go back to my graph. I'm going to find the point of intersection, the first point of intersection. Okay, quit out of that. I'm going to copy that one out and now subtract those. Okay, so determine how long a rider is 9 meters or higher in one full revolution. Round your answer to the nearest tenth. So if we round to the nearest tenth, that's going to be 4.1 seconds. Now, this is what I was talking about before, or last week, is that technically, say 4.1, guys, say 4.1 means that really it's gone a little bit below here, like minuscule amounts. So technically, we should really round that to 4.0 if it says 9 meters or higher. Because this means that there was some part of it a little bit below. But we're going to keep it to regular rounding rules. Okay? So, deal with that. On the test, then it's regular rounding. Yeah, we'll make sure it works so that regular rounding rules. But in science class, you may have to think about it to be exactly against rounding rules, depending on that. Okay, so just be aware of that. So this one, now we're going to do the same equation except for cosine. Remember I said cosine is actually easier. The amplitude is the same as the radius, but I would make this negative because then that's going to not have a translation. It starts at the bottom. And then, what did we say this was? This was pi over 8. Okay, and you wouldn't need a translation. Okay, so part B is again about Ferris wheels, so I'm going to leave that for you to do. Okay, you can check on Schoology. Oh, I didn't turn this down.